Right, let's look at the homework 6.1, problem number 9. Alright, so we want to find the area of the region bounded by the parabola and the tangent line to this parabola at the 4,64. Alright, so let's draw a picture. Alright, so we have a parabola, so it's just a regular parabola. So we have x-axis and a y-axis, and the the origin, and the parabola is going to look like this. All right, then it's a tangent line. Let's see, tangent line is at the 4,64, so that's and let's say 4 around there. All right, then you have go up here, and it doesn't look like it, but let's say this is 64 there. All right, then we have a tangent line, so here, and so it's gonna look kind of like this. All right, then with the x-axis, so we're talking about this region right here. Right, so first we need to know the equation for this guy. So let's find that. All right, so we need to know the slope. So we take the derivative of the parabola. So y prime is equal to 8x. Right, so the slope is going to be so m is equal to so plug in x equals 4, so it's gonna be 8 times 4. So slope is 32, right? And the point is here we know that x1 comma y1 will be 4,64. So by combining those, we have the equation. So you have a y minus y1, 64, is equal to 32 times x minus 4. Right? So we can go ahead and distribute 32 to both terms. We get 32x minus 4 times 2 is 8, 4 times 3 is 12, so we have that. Alright, then we can just add 64 to both sides so that we can isolate y, so it's going to be 32x, and 64 is added, so it's going to be negative 64. Alright, so got that. Alright, so let's see, we should probably do it with respect to y in this case, since if you do it with respect to x, you would have to do 2 separate regions. Alright, so let's do that. Alright, so first thing is we have to rewrite in terms of x. So this is going to be, I guess we have to rewrite it, plus 64. And that would be y plus 64 is equal to 32x. Then you would have to divide through by 32 to get, so it's 1 over 32y plus 2 is equal to x, right? And then the parabola also can be rewritten as, the parabola is sitting right here. So I'm going to divide through by 4. Alright, so we get y over 4 is equal to x squared. Then we can take the square root of both sides. So it's a square root of y, square root of 4 is 2. Then you have x. We can do a plus or minus, but we're looking at the positive one. So, alright, so let's do it with respect to y. So area is going to be, alright, so you're going to have to kind of tilt your head to the right. So top one is the line. So we're going to use that guy. So it's going to be 1 over 32y plus 2 minus the bottom one is the curve, so it's a square root of y. Actually, I'm going to write it as a square, instead of square root, I'm going to write it as a 1/2 power. Right? So we have that. And you're going from 0 to 64. Alright, so we have, let's say, antiderivative. So 1 over, let's see, y. So I'll add 1 to the power and divide by 2. So it's a 64. Right? Plus 2. Oh, actually, I wrote a wrong thing. This is with respect to y. Alright, and antiderivative of 2 is 2y. Right? And the antiderivative of, let's see, negative 1/2, add 1 to the power, so that would be 3/2 power. Divide by 3/2 is same thing as multiply by 2/3, right? Then you're going from 0 to 64. Right, so we can cancel 2 on top and 2 on the bottom. Right, then plug in. If you plug in 64, one of the 64 cancel out, so you're just going to get the 64. Plus 2 times 64 is 128. And then plug in, let's see, it's a negative 1/3. Alright, then you have, let's say, 64, square root of 64 is 8. 8 cubed is, let's say, 64 times 8. Would be what, 4 times 24, 504. So is that right? Oh, actually, I messed it up. I can't even do this. All right, so 4 times 8 is 32. Right? And let's see. 6 times 8 is 48, so it's going to be 512. So we're going to have times 512. Alright, so it looks like this is going to be 192. Alright, then common denominator is 3, so it's going to be over 3. And multiply by 3. 2 times 3 is 6. 27 and 3. So it's a 576 minus 512. So that's going to be 64 over 3. Alright, so let's type it in. So we got 64 over 3. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.